Welcome to G Fun Facts Online. The ground beneath our feet feels solid, permanent, and unmistakably Earth. We map its continents, we drill its crust, and we assume that everything down to the core belongs to us, born of the same dust that coalesced to form our planet 4.5 billion years ago. But a revolutionary hypothesis has emerged from the depths of geophysics that challenges this fundamental assumption. We may not just be living on Earth, we may be living on a graveyard, a planetary chimera where the corpse of another world still rests, thousands of miles beneath our feet. Today we are going to talk about the alien worlds buried inside our own. Buried deep within the mantle, resting just above the molten outer core, lie two colossal, continent-sized structures that have baffled scientists for decades. They are hotter, denser, and chemically distinct from the rest of the planet. For years, they were a mystery. Now, a study published in the journal Nature suggests they are the fossilized remains of Theia, the Mars-sized protoplanet that crashed into Earth billions of years ago to form the Moon. To understand the magnitude of this, we have to look at how we see the inside of our planet. We cannot go there. The deepest hole humanity has ever drilled, the Kola Superdeep Borehole, only scratched the surface, reaching about 7.5 miles down. To see deeper, we have to listen. In the 1980s, geophysicists began using seismic tomography. This is essentially a CT scan for the planet. By measuring how shock waves from earthquakes traveled through the globe, they could deduce the density and temperature of the rock they passed through. They expected a relatively uniform mantle. Instead, they found two massive anomalies. These structures are known as Large Low-Shear-Velocity Provinces, or LLSVPs. That is a dry, technical term that belies their majesty. Located on opposite sides of the planet, one beneath the Pacific Ocean and the other beneath Africa, these structures are gargantuan. Together, they make up nearly 8% of Earth's volume and roughly 6% of its total mass. To visualize this, imagine if we brought them to the surface. They would form a layer of rock 100 kilometers or 62 miles thick around the entire globe. These are not flat patches. They are towering piles, rising hundreds of kilometers from the core mantle boundary, like distinct mountains in a sea of rock. For 40 years, the debate raged regarding what they actually are. Were they just superheated plumes of normal Earth rock? Or were they thermochemical piles, perhaps dense graveyards of subducted ocean crust that had sunk to the bottom over eons? Neither explanation fit perfectly. The physics didn't quite add up. The blobs were too dense to be simple thermal plumes, but their specific chemical signature didn't perfectly match recycled ocean crust either. They were distinct, they were alien. And to understand why, we must rewind 4.5 billion years to the Hadean Eon. The early solar system was a violent shooting gallery. Proto-Earth, sometimes called Gaia, was not alone. It shared its orbit with a smaller protoplanet named Theia, named after the mother of the moon goddess Selene in Greek mythology. The giant impact hypothesis has long been the standard explanation for the moon's formation. It states that Theia slammed into Earth in a cataclysmic collision. The impact vaporized Theia and stripped off a chunk of Earth's crust, creating a ring of molten debris that eventually coalesced into the moon. But there was always a missing piece to this puzzle. If Theia was a Mars-sized planet, where did the rest of it go? The moon is only about 1/80th the mass of Earth. A huge amount of material was unaccounted for. Most people believed Theia was simply vaporized and mixed into the Earth so thoroughly that no trace remained. This was the consensus. But Dr. Qian Yuan, a geophysicist at Caltech, had a radical thought. What if Theia wasn't destroyed? What if it was swallowed whole? Yuan and his team ran advanced computer simulations of the collision. They adjusted the parameters to see what would happen if Theia's mantle was slightly denser and richer in iron than Earth's. This is a likely scenario for a protoplanet formed in a different part of the solar system. The simulations revealed a stunning sequence of events. First, Theia strikes Earth. The energy melts the upper layers of both worlds, creating a magma ocean. However, the lower mantle of Earth remains solid. Theia's dense, iron-rich core and mantle punch through Earth's crust and sink like a bullet through water. Because Theia's rock was denser, it didn't mix. Instead, it sank to the very bottom, accumulating in piles on top of Earth's core. Over 4.5 billion years, mantle convection pushed these piles into two distinct clumps. These are the very LLSVPs we see today. The model matched the reality with frightening precision. It explained why the blobs are roughly 2 to 3% denser than the surrounding mantle, and why they are located exactly where they are. We have essentially found the skeleton of the planet that died to give us our moon. But a theory is only as good as its evidence. Theia's ghost has strong supporting witnesses in the form of chemistry. The evidence comes from ocean island basalts. This is lava erupted from deep mantle plumes, such as those fueling the volcanoes of Hawaii and Iceland. Geochemists have long noticed that this lava is weird. It contains ancient isotopic signatures that don't match the rest of Earth's crust or upper mantle. Specifically, they looked at noble gases. Helium-3 is a rare isotope that is a relic of the primordial solar nebula. Most of Earth's helium-3 has escaped or been diluted over the eons, but lavas linked to the LLSVPs are surprisingly rich in it. Furthermore, the isotopic ratios of neon and xenon in deep-plume lava match what we would expect from a primitive planetary reservoir that has remained isolated for 4.5 billion years. These chemical fingerprints suggest that the plumes feeding Hawaii and Iceland are tapping into a reservoir of rock that is older than the moon itself. The LLSVPs are not just geological features, they are time capsules. When a volcano in Hawaii erupts, it may well be bleeding the ancient blood of Theia. This discovery does more than just solve a game of planetary hide-and-seek. The presence of these massive, dense blobs may have been the decisive factor that made Earth habitable. Earth is unique in the solar system because of plate tectonics. This cycle of crust creation and destruction regulates our climate, recycles nutrients, and keeps our atmosphere stable. Without it, Earth might be a Venusian hellscape or a Martian desert. But how did plate tectonics start? It is a question that has plagued geologists. A perfectly uniform mantle might have just stagnated. New simulations suggest that the sinking of Theia's remnants could have provided the necessary kick. As these hot, dense blobs settled at the core, they created powerful thermal upwellings, superplumes that rose toward the surface. These plumes could have weakened the early crust, breaking the stagnant lid and initiating the first subduction zones roughly 200 million years after the impact. If this is true, Theia didn't just give us the moon, which stabilizes our tilt and seasons. Its corpse may have started the engine that allows Earth to breathe. The collision was not a disaster, but a moment of conception. This discovery forces a psychological shift in how we view our home. We are taught that the ground is solid and static. In reality, we are floating on a dynamic, churning system, where the past is physically present. When you look at a map of the world, you see continents like Africa, the Americas, and Asia. But if you could look through the map, peeling back the skin of the crust, you would see the two true continents of the deep Earth. Scientists have even given them names. The structure beneath Africa is often called Tuzo, and the structure beneath the Pacific is called Jason. These alien continents drive our world from below. They dictate where supervolcanoes form. They may have broken up the supercontinent Pangaea. They are the silent, heavy gears of planetary evolution. The giant impact is no longer just a hypothesis about something that happened to Earth. It is a story about what Earth is. We are a hybrid planet. Half of our history is buried, fused to the core, waiting for us to listen to the seismic whispers of a ghost world that never truly left. So the next time you look up at the moon, remember that you are standing on its mother. Thank you for listening to G Fun Facts Online.